Introduction to the Astable Multivibrator using the 555 timer. Welcome to this video where we will explore the Astable Multivibrator circuit using the 555 timer IC. The 555 timer, also known as the 555 timer, is one of the most versatile and widely used integrated circuits in electronics. It can be configured in various modes, such as monostable, bistable, and astable. Today, we will focus on the astable mode, which allows the 555 timer to generate a continuous square wave without any external triggering. What is an astable multivibrator? An astable multivibrator is a type of oscillator circuit that produces a continuous stream of square waves. Unlike monostable and bistable multivibrators, the astable multivibrator does not have a stable state. Instead, it continuously switches between two unstable states, creating a clock signal or pulse train. This makes it ideal for applications like LED flashers, tone generation, and clock signals for digital circuits. The 555 timer IC. The 555 timer IC is an 8-pin device that can operate in 3 modes: monostable, bistable, and astable. In the astable mode, the 555 timer acts as a free-running oscillator. The frequency and duty cycle of the output waveform can be controlled by selecting appropriate values for the external resistors and capacitors. Pin configuration of the 555 timer. Before we dive into the circuit, let's briefly review the pin configuration of the 555 timer. 1. Ground pin 1. This pin is connected to the negative terminal of the power supply. 2. Trigger pin 2. In astable mode, this pin is connected to the threshold pin to enable self-triggering. 3. Output pin 3. This pin provides the square wave output. 4. Reset pin 4. This pin is used to reset the timer. It is typically connected to the positive supply voltage to avoid accidental resets. 5. Control voltage pin 5. This pin is used to modulate the timing characteristics. In most astable circuits, it is connected to ground via a capacitor to filter noise. 6. Threshold pin 6. This pin monitors the voltage across the timing capacitor. 7. Discharge pin 7. This pin is connected to the timing capacitor and discharges it during the timing cycle. 8. VCC pin 8. This pin is connected to the positive terminal of the power supply. Astable multivibrator circuit using the 555 timer. Now, let's take a closer look at the astable multivibrator circuit using the 555 timer. The circuit requires 2 external resistors, R1 and R2, and 1 timing capacitor, C1. Here's how the components are connected. 1. Connect pin 1, ground, to the negative terminal of the power supply. 2. Connect pin 8, VCC, to the positive terminal of the power supply. 3. Connect pin 4, reset, to the positive terminal of the power supply. 4. Connect pin 5, control voltage, to ground via a small capacitor, typically 0.01 microfarads. 5. Connect pin 2, trigger, and pin 6, threshold, together. This connection is crucial for the astable operation. 6. Connect pin 7, discharge, to the junction of resistors R1 and R2. 7. Connect the other end of R1 to the positive terminal of the power supply. 8. Connect the other end of R2 to pin 6, threshold, and pin 2, trigger. 9. Connect the timing capacitor C1 between pin 6, threshold, and ground. How the circuit works. In the astable mode, the 555 timer continuously switches between 2 states, high and low. Here's a step-by-step explanation of how the circuit operates. 1. Initial state. When power is applied, the capacitor C1 is initially uncharged. This causes the voltage at pin 2, trigger, and pin 6, threshold, to be low, which sets the output at pin 3 to high. 2. Charging phase. With the output high, the capacitor C1 starts charging through resistors R1 and R2. The charging time depends on the values of R1, R2, and C1. 3. Threshold reached. When the voltage across C1 reaches 2/3 of the supply voltage, the threshold comparator inside the 555 timer triggers, causing the output to go low. 4. Discharging phase. With the output low, the capacitor C1 starts discharging through resistor R2 and pin 7, discharge. The discharging time depends on the values of R2 and C1. 5. Trigger reached. When the voltage across C1 drops to 1/3 of the supply voltage, the trigger comparator inside the 555 timer triggers, causing the output to go high again. 6. Cycle repeats. The charging and discharging cycles repeat indefinitely, generating a continuous square wave at the output. Calculating the frequency and duty cycle. The frequency and duty cycle of the output waveform are determined by the values of R1, R2, and C1. Here's how you can calculate them. 1. Frequency. The frequency of the output waveform can be calculated using the following formula. Frequency equals 1.44 divided by the sum of R1 and 2 times R2, multiplied by C1. Where R1 and R2 are in ohms, C1 is in farads. The frequency is in hertz. 2. Duty cycle. The duty cycle is the ratio of the high time to the total period of the waveform. It can be calculated using the following formula. Duty cycle equals the sum of R1 and R2, divided by the sum of R1 and 2 times R2, multiplied by 100%. The duty cycle is expressed as a percentage. Example calculation. Let's say we have the following component values. R1 equals 10 kilo ohms. R2 equals 20 kilo ohms. C1 equals 10 microfarads. Using the formulas above. 1. Frequency. Frequency equals 1.44 divided by the sum of 10,000 and 2 times 20,000, multiplied by 10 times 10 to the power of -6. This simplifies to 1.44 divided by 50,000 times 10 to the power of -5, which equals 1.44 divided by 0.5, resulting in a frequency of 2.88 Hz. 2. Duty cycle. Duty cycle equals the sum of 10,000 and 20,000, divided by the sum of 10,000 and 2 times 20,000, multiplied by 100%. This simplifies to 30,000 divided by 50,000, multiplied by 100%, resulting in a duty cycle of 60%. So, the circuit will generate a square wave with a frequency of 2.88 Hz and a duty cycle of 60%. Applications of the Astable Multivibrator. The Astable Multivibrator using the 555 timer has a wide range of applications, including 1. LED flashers. The circuit can be used to flash LEDs at a specific frequency. 2. Tone generation. By connecting a speaker to the output, the circuit can generate audible tones. 3. Clock signals. The square wave output can be used as a clock signal for digital circuits. 4. Pulse width modulation (PWM). The circuit can be modified to generate PWM signals for controlling the speed of motors or the brightness of LEDs. Simulation of the Astable Multivibrator. In this video, we will simulate the Astable Multivibrator circuit using a software tool. The simulation will allow us to visualize the charging and discharging of the capacitor, as well as the output waveform. Here's what you can expect to see. 1. Capacitor voltage. The voltage across the capacitor will rise and fall between 1/3 and 2/3 of the supply voltage. 2. Output waveform. The output at pin 3 will switch between high and low, producing a square wave. Conclusion. The Astable Multivibrator using the 555 timer is a simple yet powerful circuit that can generate a continuous square wave. By selecting appropriate values for R1, R2, and C1, you can control the frequency and duty cycle of the output waveform. This makes the circuit highly versatile and suitable for a wide range of applications. Thank you for watching this video. I hope you found it informative and helpful. If you have any questions or comments, please feel free to leave them below. Don't forget to like, share, and subscribe for more electronics tutorials and simulations.